3. And I have here again the outline for chapter 3. And in chapter 3, we are going to introduce vectors. We're going to talk about vectors in more details. Then I will say here, whenever we are going to talk about vectors, we need to differentiate between two things. One of them, we call it scalars, and the other one is vectors. Now, or like sometimes we will say scalar quantities versus vector quantities. We will also now talking about components of a vector. There are many methods that we use to add vectors. One of them is adding by components, and you're going to see that this is the most neat, or like, the best, I would say. We should also learn how to add and subtract vectors, and how we can express vectors using unit vectors. We are going to say that now, we have examples that we did learn from vectors: position, displacement, velocity, and acceleration. Okay, and we are going to talk about finally relative motion, because it has to do with adding vectors. Now, scalars or scalar quantities are really numbers with units. I prefer to say it is physical quantities, because my things are really more than numbers. Physical quantities with, like, they can be expressed with only numbers and units. All right, and there are other quantities that, again, they are physical quantities, but they need to be represented by a number plus a unit plus a direction. These are vectors or vector quantities. Examples on scalars: distance, speed, length, area, volume, mass, density, pressure, temperature, entropy, work, power. We're gonna talk about so many in this chapter, in this course. For vectors, we have displacement, velocity, acceleration, force, torque, momentum, I will say friction, weight. Like, there are so many vectors that we are going to learn. Now, before I go over adding and subtracting vectors, I want to tell you that usually we represent a vector with a segment that has a length. Then if it is maybe, let's say, 6 meters displacement, then I'm gonna have that segment, and there should be a map scale usually that I use, and that head, we call it a head, is gonna, or a tip, is gonna show the direction. Of course, this is from math. And then I will say, maybe this is making sense when I am along just the linear or one dimension. When I add 5 plus 5, they are both in the same direction, they're gonna add to 10. If they are in the opposite direction, they're gonna subtract each other, then 0. If I have 10 and 5 in the same direction east, they're gonna add up to 15. Okay, I have 5 to the right or east and negative 10 to the, like, because it should be to the west, then I will get negative 5. And it's very straightforward when I am talking about one dimension. Okay, now adding and subtracting vectors, there is a method that we call it a method of let's say graphical method. Okay, and it is called, there is another name for it, a graphical method. As I said, we are going to use a map scale. We are going to draw our vectors in the same way that I represent there. And there is something called a tip to tail method. Okay, I'm gonna add here a page just to talk about how we are going to add these vectors, and I will show you just an example of, let's say, 3 vectors. And I will use my draw here. Let's assume I have my axes here, X and Y. And I have a vector A like this. And I have B like this. And let's assume I have C along, okay, here. And of course, I will say R, the resultant. We call it the resultant. The resultant means the adding itself. Okay, then here I will say I will draw my first vector, of course, keeping its magnitude and direction. This is my A. This is the reason why it is called tip to tail method, because I will bring my B and its tail is gonna hit the tip or the head of A. And then finally, I'm gonna draw my C, which might be something like this. Now, the one that I'm gonna draw now in green is gonna be my resultant vector, R. And I want you to imagine also, when I'm talking about resultant or adding vectors, that I can make like this separate displacement, A, then move to B, then move to C, and an equivalent of this is gonna be the R. Then R, it is a vector that is really equivalent or replacing A plus B plus C. Okay, then this is the meaning of having the resultant. Most of the time, if you have 2 vectors, we're gonna call it parallelogram method, which is gonna be like you have one of the vectors is gonna be this one, and then I will have maybe my B here. All right, then what I can do, I can bring that B here. I will be able to complete my parallelogram, and then I will have my resultant as this vector here. Okay, then this is another like way of doing it. Okay, here we are actually displaying the method again for 3 vectors. A, B, and C is the same. And here it said like they are not drawn to scale. But of course, if I want to do that, I need to do this using vectors that they should be like drawn to scale in order to get a good stuff. Here I'm listing just some of the resources for like adding vectors and subtracting vectors. I want to go maybe to this one here just to show you a little bit of, let's see here, paste and go, vector addition. Okay, then this is one of the resources that we use for, let's say, vector addition. If, oh, it's frozen here, reset. Okay, then it seems it's not like working here perfectly on my iPad. Okay, then you can show resultant magnitude. You can show triangle method, which is like I have these 2 vectors. I can also make the component thing. Like there are many things that we can work with these interactives. Okay, I will leave this maybe more to the lab. Okay, we have like so many of these here listed. If you are interested, you can just copy and paste, and you will be able to learn more about vectors. Now, also here, if we want to subtract, what we can do is I can say A plus B. This is addition. I can compare or I can convert everything to addition. Then I can say I want to subtract the two vectors. Then I'm going to get the negative of B. And this is going to be subtraction. Okay, here in this example, we have B minus A. It was converted to B plus minus A. And then we did the vector diagrams. Like if you look, B is here and this is negative A, then I will say this is the tail of B, this is the head or the tip, this is the tail of negative A, not A, and this is the head of negative A. And then my resultant, it is from the tail of the first to the head of the last. And here also displaying for you the same like parallelogram method and showing you how to find the resultant. Now, here are some of the test understanding questions, like if two vectors are given such that A and B plus B equals 0, what can you say about the magnitude and direction of vectors A and B? Okay, now if we look at that example here, you should, of course, like take some time to look at it. They should be the same magnitude, but they should be in opposite directions so that they will cancel each other. Okay, because if they are in the same direction, then they're gonna add up, and if they are in opposite direction, they must have, they will subtract each other, or like I would say take care of. Now I will say also we're gonna learn something about unit vectors, and then I will say multiplying a vector by a scalar is gonna either enlarge it or reduce it. Okay, then if you are multiplying by 5, is gonna be 5 times as bigger. If you are multiplying by 1/2, you're gonna reduce it to 0.5. If you will multiply by a negative number, you are going to reverse the direction. Now, what if you want to add or subtract mathematically instead of graphically? The graphical method, it's really very tedious method because you're going to must have a ruler, you must have a map scale, you must have a very sharp pencil, you must have a protractor, and it's gonna be like so annoying. And this is the reason why we need to add by component. I want to make this video short because I have a difficulty in uploading. Then I'm gonna stop here and I will move to the next part of chapter 3. Thank you.